Now, dear students, we have the chapter number 10, Mechanical Properties of the Fluids is there. And we have the following topics for the discussions are here. After the surface tension, we have angle of contact, concept of the cohesive and the adhesive forces we have. Now the diagrams of the formation of the angle of contact with the combinations of the liquid and the types of surfaces. Okay. Now how the relative strength of the cohesive and the adhesive forces for the nature of the angle of contact works. So we will discuss here. Now whenever we are just discussing the concept of the angle of contact, so we are just imagining this force of surface tension between the different interfaces. So here we have the three interfaces and we will discuss them by the concept of the formula. How can we discuss the angle of contact along with the forces of surface tension? The surface tension force along the surface solid and the air interface. Now surface tension force between the liquid and the air interface, and the surface tension between the solid and the liquid interface. Okay, so these are the total that mean group topics regarding to the angle of contact we have. So first we are starting with the concept of angle of contact. Now first we have the discussion of the angle of contact. So the angle of contact is generally the angle between the tangent to the liquid surface. As I am just talking, that it's simply the angle between tangent to the liquid surface and the tangent which is inside the liquid along the solid surfaces. Okay, so if we are just pouring a liquid on a solid surfaces, so generally it comes in the curved surfaces. And what are the two types of the curved surfaces we can imagine here? First is a convex surface and the second is a concave surfaces. So how it could be possible? So I am just showing. So I am just pouring the liquid on a surface. It is a type of a surface which is called the lotus leaf we have. So this is the type of the surface of the liquid comes in the existence. Okay, so here I am just saying the simply the angle between the liquid surface which is in the contact to the air and the surface of the solid which is in the contact to the liquid. So that the angle between these two tangents is called the angle of contact. Same how I am just pouring the liquid on another type of the surface, and here I have written that this is the plastic surface we have. So the angle of contact, it's simply the angle between the surface to the tangent to the liquid surface and the tangent to the solid surface which is inside the liquid we have. Okay, here I am just making the little bit changes, the surface tension between the solid and the liquid interface. Okay, now here I am, whenever I am just taking the capillary tube or the burette is there, or I am just taking the beaker in which I am just taking the water. So I have made the little bit type of the combination. Later on we will discuss, as I am just pouring the glass with the water inside the glass. So the tangent to the liquid surface and the tangent which is deep inside the liquid surface along the solid surface is called the angle of contact. This is also the part of the angle of contact we have, as I am just taking the mercury in the glass is there. So here the liquid surface in a curved manner, this is the concave meniscus, this is the convex meniscus, and this is the plane surface of the liquid is there, as I am just pouring the pure water inside the silver vessel is there. So here we have got the basic idea of the angle of contact, and simply it's a angle between the tangent to the liquid surface to the tangent which is along the solid surface deep inside the liquid. So here I have added the one of the define is there in the simpler word. Now we are just talking the meaning of the cohesive forces as well as the adhesive forces. Now the force of the attraction between the molecules inside the chemistry, you have done already the study is there, because we are doing the study of these forces here, because they decide the nature of the angle of contact. The cohesive forces, the force of attraction between the same type of the molecules of the substance is called the cohesive forces. As the relative strength of the cohesive forces is the more, so the liquid having the very much tendency to minimize its contact surface area. So one of the example we have the mercury, it doesn't mix with the another surfaces. Okay, so always it is available in the spherical shape is there for the magnitude of the cohesive forces. Now we have the concept of the adhesive forces. The force of attraction between the different types of the molecules of the substance is called the adhesive forces. So whenever we are just taking a water on a on a cloth is there, okay, so the force of attraction between the different types of the molecules is very high. So generally these kind of the liquid having the tendency to the weight of another solid surfaces. Okay, so this is the part is there as the relative strength of the cohesive and the adhesive forces changes. So how they work, so I will discuss later on. Now here what are the types of the shape, as we are just considering any type of a liquid on another surface. So here the some combinations those are given in our NCRT book. As the water droplets we are taking on a lotus leaf, so the leaf on the leaf the water droplets in a perfect sphere is there. So here we are just getting the angle of contact that is called the obtuse, and definitely this drop does not weight the surface of the leaf is there. Okay, and this is the this shape is that curved surface, but it is in the part of a convex surface. Now we are just taking the another example, or we are just considering a drop of the water on a plastic surface. Okay, so here we are just getting the angle of contact that is that acute angle is there. Acute shape or the shape is the concave meniscus is there we have. Okay, and definitely here we can say the plastic surface is to be weight by the water molecules. Okay, so here we have also mentioned the sum of the surface tension forces between the different interface surfaces. Okay, later on we will discuss it. Now here I have also added the some of the examples with the combinations. I am just taking the water inside the glass is there. So the angle that is called the acute angle, and the theta that is angle of contact is the less than 90, and this is the concave meniscus we have. And same how your chemistry teacher taught you inside the laboratory, whenever we are just taking the level of a colored liquid inside the burette, so we are just taking the convex meniscus is there. If we have the transparent liquid inside the burette is there, so we are just taking the convex meniscus is there, that is the upper surface is there. So here I am just making the glass with the concept of the Hg is there. So we are just getting the convex meniscus is there. Okay, angle of contact is the obtuse is there. Here I am just making the special combination. I am just taking the pure water for it that the angle of contact is the 90 degree we have. Okay, now same how the relative strength of the cohesive and the adhesive forces works here. Now here we can see the magnitude of the cohesive force is water droplet is quite high, so that's why it does not the weight the leaf of the lotus is there. Here we are just saying the magnitude of the adhesive forces is a much more compared to the cohesive forces, so that's why it's just flat on a surface. Okay, little it comes in a part of the concave shape is there. Okay, same how we are just taking the glass inside the water, so the magnitude of the cohesive forces is greater compared to the cohesive forces, and magnitude of the adhesive forces is greater compared to the cohesive forces, so it does not work. So it comes in the part of a concave meniscus is there. This is the magnitude of the cohesive forces is larger, so that's why the shape of the meniscus is the convex. Here the magnitude of the cohesive and the adhesive forces are equivalent in the magnitude, so equal in the magnitude. So generally the acute angle is, sorry, the angle that is called the 90 degree angle of contact, so the plane surface comes in the existence. Okay, so this is the existence of the shape on behalf of the strength of the adhesive and the cohesive forces. So here I have added the some of the things regarding to the magnitude of the adhesive forces is greater compared to the cohesive forces. Liquid weights the solid, angle of contact that is called the acute is there, concave meniscus is there. Okay, and as we will discuss the capillary, so generally in the capillary action these kind of the liquid will rises up. Okay, and here I just added the cohesive magnitude of the cohesive forces is greater compared to the adhesive forces. Liquid does not ward the wheel does not weight the wall of vessel. Angle of contact is the obtuse convex meniscus forms is here, and generally in the capillary action these liquids falling inside the capillary tube is there. Okay, so we will discuss later on this one. As we have the magnitude, those for the both the forces are equal, so we are just taking the liquid surface is the plane. Liquid surface is plane we have. Now how we are just making the consideration with the surface tension forces for the angle of contact. Now this is the one of the basic diagram, as I am just taking the water droplets on the lotus leaf we have. So how can we resolve the component of the surface tension forces? So this is the one of the component of the surface tension that available between the solid liquid interface is there. There is the surface tension force between the liquid air interface, as the theta is the greater than 90. Okay, so we are just saying this angle is known as the 180 minus theta we have. Okay, so as I am just making the resolution of the component of the surface tension forces, so one of the component that comes in a vertical direction and one of the component that comes in a horizontal direction, that is called the surface tension force between the liquid air interface, that is 1 cos 180 minus theta. As we are just saying the drop is in the equilibrium, so how can we resolve the main meaning of the forces we have? So the net that mean right hand forces are equal to the net left hand forces. Okay, as drop is in equilibrium, then net forces horizontal directions are. So here we can make the little bit, we are applying the mechanics here. SSA plus SLA cos of 180 minus theta is there, that is equal to a surface tension between the solid liquid interface. Cos 180 minus theta is equal to minus cos theta we have. So here we can make the little bit changes. SSA minus of SLA cos of theta, that is equal to the SSL is there. So we are just making the formula consideration, that is cos theta can be stated in the part of S SA minus of SSL is to be divided by SLA. Okay, so this is the general formula we have. Okay, so here we are just making the same consideration formula, as we are just taking the assumption of the water on a plastic surface is there. So same how we can discuss the component, and same thing we are just getting. This is the one of the component that surface tension liquid air surface along, that is of cos theta in a horizontal direction, and one of the component in the vertical direction we have, that is called the surface tension component, that SLA sine of theta we have, and one of the component that is acting along this direction. So same how whatever the we are just making the calculation, it comes in a same manner. Okay, so this is the calculation from the diagram first, and the another one calculation we can do. Okay, same things we are getting, but I am just representing as SA, that is equal to the SLA cos of theta plus SSL there is there. Okay, so same formula I am just getting, cos theta is equal to SSA minus SSL is to be divided by SLA is there. So you can make the comparison of the both the formula. Now we are just discussing the relative strength between these surface tension forces. Now here we are just assuming the surface tension force between the solid liquid interface is greater compared to the surface tension between the liquid air interface. So the water molecule or the any kind of the liquid having the tendency to be minimize or the contract its surface area or to keep itself away from the surface of a liquid is keep away from the solid surfaces. So at this time we are just imagining the theta will be the negative is there. Okay, and the so many energy is needed to be create inside the drop, so it does not weight the solid surfaces. Okay, so this is the consideration we have. Now second one point which we can discuss here, if we are just getting the surface tension between the solid liquid interface that is quite less as compared to the surface tension between the liquid air interface, so at this time we are just saying the magnitude of the adhesive forces is greater compared to that part. So here we are just saying कि थीटा का जो वैल्यू है वो इंक्रीज होता है, बट कॉस थीटा जो है वो क्या होता है, डिक्रीज होता है. ओके, थीटा की वैल्यू इंक्रीज हो रहा है, कॉस थीटा डिक्रीज होता है. दैट्स मीन थीटा की वैल्यू जो है वो आपका जो है वो डिक्रीज होता है. सॉरी, आई हैव जस्ट टोल्ड द लिटिल बिट. I'm just making the little bit correction in this part. As the theta is decreases, as the theta is decreases, so the cos theta value increases. We have, okay. So little bit I am just making the correction. As we are just increasing the meaning of the theta, that is decreases, so the meaning of the cos theta we have, that is called the increases. Okay, so many consideration we can add here. If we are just getting the third point that comes in the part, as SSL is equal to the SLA. So we can imagine the simply the part that mean cos theta is equal to 0. So cos theta comes in the part of the 0 we have. So we can imagine the theta is equal to 90 degree we have. So the relative strength of the surface tension make the discussion on that part. Okay, so it comes in the part of the obtuse and the acute is there. So this is the negative we have, so it comes in the part of obtuse, so it comes on in the part of the acute we have. And same how we can imagine here the theta is the 90 degree, so the plane surface comes in the existence. Okay, so this is the angle of contact on behalf of the relative strength of the surface tension between the different interface surfaces here. Okay, so this is the all about the angle of contact. I think you are just doing your own preparation, so you must include this one topic in your preparation. Okay, thank you.